So the materials that you should have a calculator, or as long as it's not a quiz or a test, you can use your phone calculator. But if it's a quiz or a test, you can't. So we also have the reference sheet that you received with the conversion factors. You always want to have this in your folder, because even if this isn't the main topic of the day, this is really useful. It has all your information you need for conversions on it. And then this is the new sheet here, okay? Dimensional analysis, single step is what it says on the top. So just to kind of let you know what's happening, the intention is you're gonna do number 1 and 2 and 4 and 6 and 8, okay? So those are the ones that you're gonna do. You may already know how to dive in and begin from the previous lesson. I'm gonna do these other ones, 3 and 5 and 7 and 9, to help out anyone who needs some more help with this. So here we go. I'm gonna start with number 3, okay? So the first thing that we do with this method of problem solving is we copy down what they give us, okay? If you feel like this is confusing and you're staring at it, that you have to get started. The first thing to do is to copy down the number and the unit that they give you, okay? Number 3 is interesting because these are units of pressure. Atmospheres and pascals are units of pressure. And chances are you've never heard of those because we haven't really talked about pressure yet. However, the big idea here is if you understand this method of problem solving, as long as you have the conversion factor, the equivalency statement here, you can solve these problems and not even know what those units mean. That's the beauty of it. And I consistently tell my students, if you embrace this method of problem solving, it's going to carry you through physics. It's going to carry you through other classes in the future. It's really a useful method because a lot of different areas of science use it. So let's go ahead and dive in. These are units of pressure. And if you don't know what that means, if you take the palm of your hand and blow on it, you'll feel that air hitting it. And that's pressure coming from the air, and the atmosphere around us is always applying pressure on our bodies because of the air that we're in. We just don't notice it because the inside of our bodies is applying an equal pressure and it all seems to equal out. But if you've ever seen a balloon explode because you put too much air in there, that's the pressure that was building up in there, and it got to be bigger than what the balloon could withstand, and so then the balloon went pop. Okay, so let's dive in. We're going to start out with our number. I like to work in pencil because then I can erase mistakes, okay? I'm going to go ahead and copy my number. Make sure I write my unit with it. So there, I'm seeing if this is going to be, yeah, that shows up good. So there we have it. Now I'm going to look for an equivalency statement that can connect me with atmospheres to pascals, and they gave it to me. So now I'm going to take this and I'm going to put it in the form of a ratio. Okay, so either I'm going to put ATM in the numerator and Pascal in the denominator, or I'm going to put Pascal in the numerator and atmosphere in the denominator. It's going to be one of those two, okay? And regardless of which one I do, the number is with the Pascal. So I'm not going to ever put the 101.325 with the ATM. It's with the Pascal. And I have to be careful, especially with units that I might not really understand, to put the number where it belongs, okay? I'm gonna have to squish that because I'm running out of space. So now I'm gonna pick, is this the ratio that I wanna use here? Or is this one? Which one? Well, you look at the unit that they start you with, and whatever that unit is, that needs to be in the denominator of the next step. That's the name of the game. If this atmosphere, ATM, is in the denominator, it's going to cancel. It's going to give me that other unit, okay? So I'm going to go ahead and put my line in, and I'm going to put 1 ATM. See, I got it from there. And I'm going to put 101,325 Pascal. Okay? And so there's my conversion factor, and atmosphere cancels. I'm going to get Pascal as my answer. That's what they asked me for. Grab your calculator. Remember, anything, you start with the number they give you, and then anything that is in the numerator, I'm going to multiply that, divide by anything in the denominator. So I am going to take 0.58 times 101,325, and dividing by 1 doesn't change anything, so you can skip that. But if you feel like you need to put the divide and the 1 in your calculator, that's absolutely okay. And the number that you're going to get is, from the calculator, is 5878.5, and then our Pascal is the unit. Now, that's the unit that you get, okay? Now, this is where these discussions of significant figures are so important, because think about it. If the estimate in the original measurement was in the 1/100th place here, how are we going to report a number with all these numbers for our answer? Because that's why we talk about significant figures. So what I'm going to do is I'm going to look back at my original measurement. It has 2 significant figures, and the correct way to round this would be to have 2 significant figures. So I have a decimal. I want to make sure you see that this is a decimal. It's not a very good decimal. There we go. So I am going to keep the first significant figure. I'm going to keep the second significant figure, okay? And then I'm going to only keep those, okay? So is 7 big enough to make the 8 round up? It is. So I'm going to take 5 and 9, and then I'm going to make these placeholders 0, 0, 0. Okay, I'm going to just lose that 0.5, and then the real question is, do I want my decimal point to show? Well, if the decimal point shows, then those are all significant. If I leave the decimal point off, I'm showing 2 significant figures. So the textbook answer would look more like this, but if you got to this, and that's what I like to call that a kick-out number, it's what the calculator kicks out for me, then I'm really happy with your work if you got to here, okay? But I'm going to show you what this whole significant figure thing is about, and it's about how we round when we do calculations. That's the whole purpose of it. So great if you could get to here. Always show your unit, okay? Always show your unit, right? So numbers 1 and 2 are easier, so you could just put this video on pause and go back and do those. You're going to have one equivalency statement. Okay, you're going to decide to put whichever piece in the denominator that is going to have the same unit as the unit that you started, so that they'll cancel. Okay, I am going to look at number 4 now. So how many milliliters are in 67.8 liters? Now, we've just did the lesson on moving the decimal if we're looking at the chart. So technically, you could do that if you have that chart, or if you memorize that chart. However, this lesson is about dimensional analysis, so I'm going to do it using dimensional analysis. And what I want to do is I want to figure out, what do I know about how liters and milliliters are related to each other in terms of an equivalency statement like this. So I'm going to go ahead and go to my reference page, and I'm going to look. And so here are my liter equivalency statements. All of these are equal to each other. All of these are equal to each other, okay? So we're gonna know that 1,000 milliliters is equal to 1 liter. I want these, okay? So this is telling me that 1,000 milliliters is equal to 1 liter. That's what I'm getting from this, okay? All of these things are equal to each other. That gives me an equivalency statement that I can use right here in my problem, okay? So I'm gonna start out by copying what they give me, okay? Okay, and then you're going to use this equivalency statement here to finish that. Make liters cancel, end up in milliliters, okay? Gave you a little help with that one. Okay, number 5, kilometers. How many kilometers are in 2.46 times 10 to the 5th meters, okay? So we're going to copy down what they give us, and look at that. It is in scientific notation. Okay, so now first of all, I know that you're probably looking at that scientific notation. I'm going to talk about that. But first of all, let's find something that connects our meters and kilometers. Okay, I'm going to go back to my page here, and here I have meters and kilometers right here. Okay, all of these things are equal to each other. Okay, and we've got 1 kilometer is equal to 1,000 meters. That's my conversion factor that I'm going to use. Okay, 1 kilometer is equal to 1,000 meters. And if we remember all of our prefixes, and we remember what kilo means, okay, we could maybe remember that, but we don't need to memorize everything if we've got a handy reference sheet, which you have. So now I've got meters. Now, I'm going to set this up, okay? I want meters to be in the denominator so that it cancels. So I'm going to put my line in. I'm going to put 1,000 meters. I'm going to put 1 kilometer in the numerator. So when my units cancel, meters are going to cancel. I'm going to get kilometers. So now, oh no, how do we do a calculation with this scientific notation? Well, since the exponent is only 5, honestly, you just learned how to convert things out of scientific notation. So if you want to, move the decimal over the 5 places and rewrite it. You can do that, okay? That's nothing wrong with that. And 5 isn't a whole lot. That's not going to give you a whole lot of zeros to play with. But there is a thing on your calculator. If you have a scientific calculator, you're going to want to look for this. In this calculator, it's the EE button, okay? In a lot of calculators, it'll say EXP. It will say, I'm writing this, but you can't see it, okay? It will say EE. Sometimes it will have something like a times 10, and then it'll have like an X up there or something like that. You'll see a button like that. But that's a button that's specifically for scientific notation. Most of the calculators I use have one of these two, okay? And in this calculator, if you want to use any of the functions that have yellow, you have to push the second button, and then that button that has the EE above it. So I'm going to push the second and this EE, okay? And so I'm going to show you how I can put that right into the calculator. And even your phones, you can switch your calculator to a scientific calculator. So I'm going to put 2.46 into my calculator. Okay. And then this EXP thing, okay, whichever one yours looks like, this takes the place of the times and the 1 and the 0. So when I hit my second EE, see how that E says it already knows I'm going to talk about scientific notation. It's just asking me for the exponent now, and I put in a 5. okay? So that number is already in there in scientific notation. And then in my problem, I want to divide by 1,000, so I'm just going to hit the divide key and put in 1,000. And then hit equals, and I got 246. So my answer is 246, okay? And I have kilometers. Okay, now, but again, if that's way out of your comfort zone, we just took a quiz on scientific notation, so I can take my decimal point, move it over 5 times. That's going to give me 246, 1, 2, 3, 4, 5. Feed that number into your calculator, hit the divide key, put 1,000. You should get the same thing. Do you not believe me? 246,000, okay? Divide by 1,000, hit equals, and you get, oh, I only divided by 100, I'm sorry. Do that again. 246,000 divide by 1,000, and there it is, 246. I got my camera set up a different way than I normally do for these videos, and I can't see what I'm doing, but got to keep moving. All right. Okay, so there we have it. Okay, on the back. Now, if you are doing this yourself, make sure you do the ones that you're supposed to do on the front. Pause this so that you can think straight about those before we start talking about a 2-step problem, because that's what you're going to do in number 6. I'm going to do number 7 for you, okay? So number 6 I left for you because they give you the conversions. You don't have to go on the other paper to look for them. That's why I left that for you. Here, I'm going to have to go look for those, okay? And I'll show you how I do that, okay? And I'm just going to fold this because it'll work better for me while I'm trying to. Okay, so here we have how many kiloseconds are in 5.9 hours. Well, I'm going to go over here to my reference sheet, and there's a section in here on time, and what it says is 1 hour is, here it is, 1 hour is 3,600 seconds. So I'm going to literally write that down over here in my workspace. 1 hour is equal to seconds, okay? That's one of my useful conversion factors. The other thing I want you to realize is when you come up here, okay, it's talking about kiloseconds, and it's not mentioned here. However, the prefix kilo hasn't changed. It's going to mean the same thing no matter what. So if 1 kilogram is equal to 1,000 grams, and 1 kilometer is equal to 1,000 meters, and 1 kiloliter is 1,000 liters, guess what? 1 kilosecond is going to be equal to 1,000 seconds because the prefix kilo hasn't changed. So I'm going to put that there for myself too. 1 kilosecond is going to be 1,000 seconds, okay? So there, I have my 2 conversion factors, and my S's look too much like 5s, but, you know. Okay, so I'm going to start doing my work now. I'm ready to go. I'm going to copy what they give me, okay? And that is 5.9 hours, okay? And I'm going to put my conversion factor in. I want hours to cancel, so I'm going to choose to make hours in the denominator, okay? And 1 hour is equal to 3,600 seconds, okay? And bam, hours is going to cancel, and I'm done there. Now, I don't have the answer that they're asking me for, And I do have another conversion factor that I can use. So I'm just going to keep going, okay? I'm going to put, this is like an invisible times sign in there, and there's an invisible times sign in there because we're multiplying these factors. I'm just going to put the second one in. I'm going to draw my line again, okay? And this time, I want second to be in the denominator so that kilosecond gets left. So I'm going to put 1,000 seconds, that's my S, and 1 kilosecond in the numerator. And now this is what a two-step conversion looks like, okay? And I'm going to multiply by everything in the denominator and divide by everything in the denominator the same way I did before. So I'm going to take 5.9, start with the number they gave you. I'm going to multiply by 3,600. I'm technically dividing by 1. I can skip that or not. I'm going to multiply by 1. I can skip that or not, because multiplying and dividing by 1 don't change my number. And then I'm going to divide by 1,000, okay? So 5.9, okay, times, there's my 3,600, I'm going to divide by 1,000, and I got 2124 as my kick out number, okay? What unit is that going to have? Well, it's not going to have hours because that canceled, seconds canceled, and I have kiloseconds as my unit in my answer, which is what they're asking me for, okay? So now, again, if you're here, excellent, wonderful, you're doing everything I expect you to do and more, you're fantastic, okay? But what's the deal about the fact that that has two significant figures there? So because that has two significant figures, what I would do, okay, so I've been doing significant figure stuff a little longer than you have, so I'm going to look at that and know that there's two significant figures in my original measurement. I want my answer to be expressed with 2. I want 1. I want the second one. 2's not enough to make that round up, so my answer is going to say 21 kiloseconds, and that's my final answer, okay? Again, if you're here, you're doing everything I expect you to do, okay? Good job. Try number 8. It's also going to have 2 steps, and the conversion factors are given to you, okay? And then number 9, they give you part of it here, okay? You've got ounces. You want to know kilograms. They're giving you the conversion ounce to gram. You're going to have to convert also to kilogram with the second one that you get on your chart. And so you're going to start out. You're going to write what they give you, 13.8 ounces, okay? So if you came to me and you hadn't even started to write down what they gave you, then you're not diving in. Dive in. You learn this by practicing, making some mistakes, and then looking at what mistakes you made. So I want ounces to be in the denominator because I need it to cancel out, and I've got 1 ounce is equal to 28.3 grams. So I'm going to put 28.3 grams in the numerator. I've got 1 ounce in the denominator. Ounce is going to cancel. Now I have to figure out my next step. It's going to convert to kilogram, and I can come over here, and there it is. 1 kilogram is equal to 1,000 grams. So I want grams to be in the denominator because I want my answer to be in kilograms. So I'm going to make my next step, and I've got 1,000 grams, 1 kilogram. Okay, that didn't come from outer space. I looked. Okay, I looked. So now gram is going to cancel. My answer is going to be in kilogram. Okay, I know it's mathy, but hang in there. So now I'm going to take my calculator. I'm going to start with what they gave me. I'm multiplying by everything that's in the numerator, dividing by anything that's in the denominator. So 13.8. okay? I'm gonna multiply by 28.3, and now I'm gonna divide by 1,000, and equals, and I get 0.390. And then my kickout number has more things. 0.39054, okay, kilogram is my unit, but do I really want to express information? Let's see, this is the 1/10th, 1/100th, 1,000th, 1/10,000th. This is the 1/100,000 space. That's the value of that 4. How can I talk about 1/100,000ths of a unit when my measurement gave me only information about the 1/10th space? That seems off. I can't talk about the 1/100,000th or the 1/10,000th units when my measurement really wasn't that precise. So I am going to count my sig figs, 1, 2, 3, and I'm going to answer round to 3 sig figs, 1, 2, 3. This is a fun one because 5 is big enough to make that round up. So 0.391 kilograms is going to be my answer, okay? Again, the sig fig stuff is a little uncomfortable for you. That's okay. Get here, and you're good, okay? It's high school chemistry. Get here, okay? Yes, I aspire to have you here someday, okay? But if you're here, you're good. You're good. This one is very bonusy, okay? If you want to play with it, play with it. I'm not assigning it, okay? I'll show you the answer to it so that you can be amazed at some point. But if you are loving what we're doing, you know, and you want to tackle it, tackle it. If you don't, skip it. It's fine, okay? And that is that. Thank you for your awesome attention, which I hope you're giving, because I know math isn't fun for some of you, but hang in there. Bye.